Hello everyone, am I audible?
Yes, miss.
Thanks. Okay, we will start today's talk. So, as you know, we are trying to solve the last year questions today, but I think we have left with this one concept of small oscillations. So, I just thought to cover this small oscillation and solve the doubt that is posted on Telegram. I have received two, three questions. So that then we will solve and also solve the questions related to this small oscillation part. And there is around one to two questions that was appear from this topic alone. And they are very straightforward to solve if you understand this concept clearly. So we will started it today. So it's just a continuation of stable and unstable equilibrium lecture that we have done previously and also phase space trajectory. So small oscillation is just a next part of this continuation of lecture. So in small oscillation, they are basically talk about the motion which are more like simple harmonic motions. Like we are talking about the small displacement. So I think you are familiar with the simple harmonic motions in which you have a spring which is like with no friction, no mass, and inextensible string. So if you give a small displacement to this mass, it will start oscillating about its equilibrium positions. And that kind of motion is known as simple harmonic motions. And if you understand mathematically, that means your potential energy is just a function of square. There is no higher order term like s c cube or x to the power 5 or 4. So if your potential have the highest power, which is like x squared, then your motions will be more like simple harmonic motions. And in that case, your force will be proportional to negative of your displacement. And that's why it is known as restoring force. I think you are all familiar with this case that if your potential energy is given by V, then you can calculate your force by minus del V by del X. That's from this relation, your force is proportional to displacement. And this is the case. If this condition is satisfied, you can say that your motion is like simple harmonic motion or small oscillation. And omega in this case is constant. So omega is like this oscillation frequency of this mass m about this position. So it is going to have a constant frequency if it is moving with simple harmonic motions. So most of the time, our questions are related to these oscillations, which are small oscillations. So we are trying to make all our programs so that we can solve it using these formulas. But that is the case for one mass. If you have two masses, then motion of one mass affect the motion of another mass. Like if you take this mass and you just pull it this up in another direction, then the motion of the second mass is also influenced. So overall system will start oscillating with a frequency which is different from the frequency of mass m1 and m2 alone. So complete whole system have a frequency which is combination of these frequency which is of mass m1 and m2. And that kind of motion in which one particle motion influence the motion of other particle is known as coupled oscillations. And we will see how we can solve this kind of problem. And the overall frequency by which your whole system is moving is known as the normal mode of motions. So basically, most of the time in question that was asked in GATE exam, they will ask you what is the normal mode of frequency by which your system is oscillating. So by normal mode means they are not asking the frequency for mass m1 or m2. They are asking the overall frequency of your system. So before going into this formulation, just understand if you are not uh, using the formulation of simple harmonic motion, how you are going to solve this kind of problem. So you have a mass M1 which is attached with a string, and which string is fixed on the wall. And similarly, the mass M1 and M2 is attached with a string K, and then a third string which is attached on a fixed wall. So we have two masses M1 and M2. So we can write our generalized code for both two these masses separately, X1 and X2. So X1, X2 are the equilibrium position of this mass, and when there is no force, there will be like a certain equilibrium position, and this is X1, X2. And now if you give a small displacement to any one of these masses, the system all start oscillating with some frequency, and we have to find out what is that frequency is. So we can write the Lagrangian of the system and write the equation of motions. From that we can calculate what is the oscillation frequency. So for writing Lagrangian, we must know what is the kinetic energy, potential energy of the system. So the kinetic energy is given by kinetic energy of first mass plus kinetic energy of second mass. I just write x1 dot, which is the velocity of first mass. So I just use dot notation here. So the kinetic energy is given by this, and the potential energy is um, the most important thing in solving this type of question is how you are going to write your potential energy. So for example, here mass m1 is there. So if initial if final position is x1 and the string, you have to calculate what is the total displacement for this string. So initial one is fixed, so x2 1 minus x0 for this is for this spring. So potential energy from one string is kx1 square. For this string, the position is x1 initially and the next one is x2. So the displacement is x2 minus x1. So for this middle string, this is the potential energy. And for this one, this is x2 and this one is fixed, so it is not going to change. So you have x2 minus 0. So for three strings, you have just write the potential energy. And if you look at this middle spring, it is kind of interacting between M1 and M2. So this is also correspond to the interactive potential energy. So you just write your Lagrangian, which is kinetic energy minus potential energy. And as you know, the Lagrangian equation of motion is given by dt of del L by L Q dot minus del L by del Q in generalized coordinate system. Since we have two coordinates, one is x1 and another two is x2, so we have two equation of motion. One which corresponds to x1, another one which corresponds to x2. So we have two equations here. I think you people know how to calculate this del by del x dot. If I have to calculate del L by del x1 dot, I just take only the one which have x1 dot explicitly. So only this coordinate is going to be affected. It will give you mx1 dot. And when you do it d by dt of del by del x1 dot, it will become mx1 double dot. So I just type this term here, and when you calculate del L by del x1, so you have to find out x1 explicitly in this expression and in this expression. When you differentiate this, it will become kx1, and when you differentiate this one, it will become, oh, there is a minus sign in here, and it is k minus x1 and with minus sign, so this will become plus. And if you write k as m omega square from this relation of simple harmonic oscillation, where omega 0 can be written as square root of k by m. So if you replace your k by m omega 0 square, so basically this is k. And I just write by dt term and this and del L by del x1 term and put it equals to 0. Similarly, I have done this for x2. So we have the two Lagrange equation of motion corresponding to the x1 as well as x2. And now we have to solve these equations. And if you look at these are kind of more of a linear differential equation. They are like m d2 x by dt square plus omega square x1 minus omega square x1 minus x1. So this is like I think I've solved this equation in 12th also how to solve this linear differential equation, but they are in second order. So one of the way to solve this equation is just assume that its form is like exponential form a to the power alpha t. And since this is the solution for this equation, so we just put the value in first equation and we are ended up having. Are you comfortable with that? If I take x1 as ax, then x1 double dot is like differentiation of this term twice. That will give you alpha square term here. And this side x1 using that. See, if you I give you x1 and I give you the equation x1 and x2 and I give you the equation, then you just put the value inside the equation, differentiate it this expression twice for x1 double dot and for x1 put it as it is. You ended up having these two equations. And since these two equations in terms of A and B, you can always write in terms of matrices. Like A coefficient of A and coefficient of B, coefficient of A and B. So you have this kind of matrix. And once you solve this determinant, since A and B are constant, they cannot be zero. Otherwise, your x1, x2 will become zero. So the only way to solve this equation is if this determinant is zero. So when you put this determinant equals to zero, so you are just having alpha square plus 2 omega 0 square ka whole square minus omega 0 to the power 4 equals to 0. From there, if you calculate the relation between alpha and omega, this is the expression you are ended up. And by putting value alpha back into this expression x1 and x2, since we have value of alpha, actually 4, 2 negative, 2 positive. So we have x1 values in terms of exponential. And since we are dealing with the linear system, so their combination of these terms is also the solution of the equation. And if we try to write it in real form, so combinations means we have two terms in our solution, one which is corresponding to frequency omega naught, another one which is corresponding to the frequency square root of 3 omega naught. So even though our original frequency mass m1 may be omega 1 and mass m2 may be omega 2, but our overall system is moving with the frequency omega naught and square root of 3 omega naught, which is different from this initial frequency of m1, m2 alone. And this frequency omega naught and square root of 3 omega naught are known as the normal modes of this system. So this kind of a tedious task if you do it this kind of way manually, but we will see how we can do it much more effective way. We just write the formula so that we can solve all kind of problems. But there is a traditional way to solve this problem is this one. So for example, we might have a lot of masses with lot generalized coordinate x1, x2, x3. In that case, to solve the equation, we are trying to write more general formula. So let's say we have a potential which has generalized coordinate q1, q2, q3, and q. So q1, q means x1, x2, and x3. I just replace with generalized coordinate q1, q2. So those who have taken the Lagrangian Hamiltonian class, they are familiar with this notation that we can always write our x, y, z in terms of 1, q2, q3. You can go back to this lecture. And let's say we have a stable equilibrium point. So we have a potential which is like multi-dimensional potential, and we have some equilibrium point qi0 for ith direction. Like say if I plot my potential in x-axis, and then x10 is my like equilibrium position. So qi0 is like x10 here. And in if I plot it in y direction, then it will become y10. So we have qi0, qj0 as our coordinate of a stable equilibrium point. So we can always do the Taylor's expansion about this equilibrium point. So I think you have taken the stable equilibrium and unstable equilibrium class, which we have our potential Ex, and we just do the Taylor series expansion about the equilibrium point, in which we just write del v by del x around x equals to x naught, and 1 by 2 x minus x 0 square del 2v by del x square. So this is for one dimension. For n dimension, if we do the Taylor series expansion, this is how it is looking. We have one term which is constant, and then we do this expression which is like this, and it is equals to 0 for the equilibrium position, and the second position will this second derivative will decide whether we are going to have stable or unstable. For stable case, this is positive, and for unstable, it is negative. So in multi-dimension, this term corresponds to this term, and we have neglected the higher order term. So if we look at this is constant, we just take it as O maybe. This is 0 because of equilibrium condition. So we are just left with this term only. And if we replace our coordinate system y minus c0 by some another coordinate eta I, I have taken eta I, but it could be anything. We will see how we can use this for our calculation in question as well. And this is just change the coordinate system. And since this is constant, qi0 is some position about equilibrium. So if you take dqi minus dqi0 like differentiation on both sides in this equation, so it will become dqi equals to d eta I. So these terms is not going to affect inside this expression. So only this term will become eta j. This term will remain as it is. So instead of using simple potential, we are dealing with a matrix form of potential here. So matrix means this is an see, when you have one dimension, you just differentiate it with respect to z. But when you have n dimension, you have to take care of a dimension like del 2v by del x del y and del 2v by del y square as well. So if you take care of other dimension coordinate, this is the term that you are ended up, and it's a matrix and cross and Jacobian if you have an element. For example, I can write for two dimension like x and y. So it will become del 2v by del x, del 2v by del x, del y. So basically, most of the time you are dealing with this kind of system, which are like two dimension or at max three dimension. So this Vij is now become matrix. Similarly, your kinetic energy, which is 1 by 2 mx dot square, you can also write it like x dot into x dot. And for n different element, it become xi xj dot. So your kinetic energy will also become a matrix. This is given that T del to T by this term. And we can write x as neta as well. So basically, you have to write your Lagrangian. So whenever you are given some kind of system like this, write the Lagrangian, write the kinetic energy as 1 by 2 this term, write the potential energy as 1 by 2 this term, and then solve your equations of motion. So I just solve equation of motions. So this will become the previous equation that you have solved for simple harmonic motion case, one dimension. These three equations are same. So I think you are familiar with this equation of motion in simple harmonic motions, like x double dot equals to minus omega square x. This is the same equation for n types of particle. And as we have done, if we take our solution to have exponential it and put this into this equation, So you are ended up having this equation. And the solution for this equation is when this determinant will become 0. So this is just same analogy that we have solved for this equation. So whenever you have, you know, this type of system, just write your potential energy, write your kinetic energy, multiply by omega square, take their determinant equals to 0, and from that determinant you are ended up having some value of omega, and that value of omega is known as the normal mode of your system. And they are just very simple calculation. This calculation is just to write your potential in the Taylor series expansion, put the constants term as 0, and just change your coordinate system and simple mathematical manipulation. So this equation is known as secular equation. So if you are able to write secular equation for a small oscillation case, you can solve all your problems related to small oscillations. So for it, there are certain property that if your system is like it is not fixed to certain wall, like it, you may have this kind of system or you may have this kind of system. So since this system is fixed, so it cannot translate, but this system can translate to another direction as well. So in that case, you have one solution of angular frequency which is 0, and that we will see in next questions as well. And another thing is the number of, if you have n cross n equation, that means you are going to have omega values which are n. So the solution of this matrix determinant will give you n values of omega, and these n values are known as degree of freedom of your system. And there are certain values of omega. The smallest one is known as the fundamental frequency, and the highest one is known as the first harmonic, and then second harmonics. Okay, so we will solve some questions related to that. So this is the problem that
एक्सक्यूज मी मैम। हेलो मैम, आपने ओमेगा इक्वल टू जीरो लिखा है, तो ओमेगा
hmm,
इक्वल टू जीरो किस कंडीशन में लेते हैं हम?
ओमेगा इक्वल्स टू 0 हमारा सॉल्यूशन आएगा उस केस में जिसमें मैट्रिक्स, जिसमें क्वेश्चन कर सकते हैं पार्टिकल्स, मीन्स उनका जो स्ट्रिंग है वो
मतलब
फिक्स नहीं है किसी वॉल से.
हाँ हाँ।
If it is fixed with some kind of wall, then omega cannot be 0 because there is always a oscillations in that case. But if you have this kind of system which is not fixed to some wall, they can move na, they can move in this direction. So in that case, it is possible for the system to move without oscillating. So that means your angular frequency can be 0.
यस यस, गॉट इट।
Okay. So this is the problem that we have solved just before doing this derivation. We have two masses and we have three springs and they are fixed by some wall on both sides. So what, whenever you try to solve the equation, write the Lagrangian. Write your kinetic energy and write your potential energy. Since you have two particles, so you have to x1, x2 as your generalized coordinate. So write kinetic energy as kinetic energy of first particle plus kinetic energy of second. And when you are writing potential energy, just look at the displacement of individual springs. For this spring, one is attached, so you have this spring, there is no displacement in this direction. In this direction, it is about equilibrium position. So you have final minus initial. So x1 minus 0. So this is for first spring. And for this case, you have spring can extend in both direction. So x1 is can also change, x2 can also change. So your final displacement will be x2 minus x1. And in this case, this one will fix, so it cannot change. So your this is the for third spring. So this is your kinetic energy minus potential energy. Then write your secular equation, which is determinant of omega square t minus p equal to 0. Write t in terms of matrix form, which is That to xi dot xj dot xi and j can take values 1 to everything. So T1, T1 to T21 and T22. So this is T11 means del 2 T by x1 dot square into x2 dot 1 dot square. So it will become as differentiation with respect to x1 only. So 1 2 means if you have one as x2 dot and another one x1 dot. So this matrix is symmetric. T12 is equals to T21 and then you have T2. So when you write your matrix T, just differentiate this with respect to, if you take your T and del to T by del x1 dot square, so what is it left? There's no effect on x2, just only x1. You are left with m1, x1 dot, and then you again do it with del by del x1 dot. So you are left with m1 only. This is how your matrix is formed. Similarly, if you wanted to calculate del 2 by del x1 dot x2 dot, how you calculate it? You first calculate del L by del x2 dot, and then calculate del L by del x1 dot. So x2 dot means this term only going to effect. So you are left with 1 by 2 m2 x1, no 1 by 2. It cancel out. And when you do del L by del x1 dot, since there is no x, so it will become 0. So this term is 0. Similarly, you can calculate this term and this term too. Then you have to also write your potential energy in matrix form. So this is your matrix for potential energy. This is V11, V12, V21, V22. If you look at this expression here, this one, they are just trying to tell you the same thing that you have to write your potential energy and kinetic energy in matrix form. So when you calculate V11 means del 2V by del x1 square. So del V by del x1 calculate, then calculate one more time. So del V by del x1, we have x1 here and also x1 here. So that this means we have one is the term for x1, kx1, another one by x2 minus x1 square. Okay, x2 minus x1. And there is minus sign too. When you apply chain rule, so it will become minus. And then you have to again take del x1. So this will become k plus k like 2k. So this is your first element. Similarly, you can calculate these two. Basically, it's a Jacobian matrix. And just multiply omega square with this term inside and just subtract these two matrices and just calculate the determinant of this, put it equals to 0. And now you have this quadratic equation. You can solve it your way, whatever the formalism you wanted to take. So you can see that your omega comes out to be square root of k by mu. Yeah, but this is not to be like that in this case. We will solve a problem where we can solve the complete solution. But then how you are going to tackle all these problems with small oscillation? The potential energy, put the circular equation equals to 0 and write it in matrix form. And you can solve all problems related to that. This point I have already told to you. Now let's solve this problem from it exam. So you have this question was from K 2014. So you are given two masses m and 2m and are attached to the two ends of massless spring with force constant K. If mass m is 100 gram and K is given, then what is the natural angular frequency of oscillation? So you are given a kind of conditions in which two masses are attached to a spring. And since they are not attached to some kind of wall, so there is no fixed attachment to of the spring to a wall. So you are just sure that one frequency is going to be zero in your solution, and you have to find another frequency. So the kinetic energy of first particle and second particle. Mass m1 is m and mass m2 is 3m. And let's consider that since there is no position, equilibrium position is not known, we can take x1 and x2 as equilibrium, but initial position might be different. So we can take initial position like x01 and x02. So the potential energy will become in this case as k present length minus previous length. So present length of this spring is x2 minus x1 minus the previous length. Maybe it might be some inside, so that x2 minus x1 square. So this will become your potential energy. And we are going to change our coordinate system so that we can compact it more clearly. Since x01 is just a constant, so you can just write x1 minus x01 as theta 1, x2 minus x02 as theta 2. So your x1 dot will become differentiation with respect to tan t. So this one is constant, it is not going to be affected. So only theta 1 dot will remain as it is. Are you able to get this point? That if I take del by del t of x1 minus x01, it's just going to give me del x1 by del t. Since this del x01 by del t is going to be 0, it is a constant initial position. So I just changed my coordinate system in terms of neta 2, neta 1, and x1 dot x2 dot is similar to like neta 1 dot neta 2. So my kinetic energy also get transformed in these two coordinates. So kinetic energy will become 1 by 2 m neta 1 dot square plus 1 by 2 3m in the second mass neta dot 2 square. So I just write our coordinate in neta 1 neta 2 and just write the circular equation. And since we have two coordinates, so your matrix will be 2 by 2. So you can always decide your size of matrix, how many generalized coordinate you are using. So you can just do the same analysis here. There is a dot here. So differentiate with respect to eta 1, differentiate with respect to eta 2. This will give you kinetic energy as a matrix form. Similarly, you have your potential energy. If you differentiate it with del B by del eta 1 will give you K N2 minus N1 with a minus sign, and del 2B by del eta square means differentiate one more time. So that will give you K only. So this is your first element. Similarly, you can also calculate the other element as well. Put it inside this equation, omega squared T minus V equals to 0. And solve this determinant. So you are ended up having this equation. You can just write it in more clear form. And when you solve this equation, you have two values of omega. One is 0 as expected, and another one is square root of 2k by 3m. And since k is given to you 0.3 and m is given to you as 0.1 kg, 100 gram means 0.1 kg. So we just calculate our angular frequency, which is 2. The question is ask the angular frequency of oscillation. From that, the answer should be 2, but the answer is asking in terms of hertz. Hertz means you have to calculate the normal frequency, which is 2 pi f equals to omega. So that means f is equals to omega by 2 pi. So you just divide your answer by 2 pi, that will give you the factor here. Okay, so that was,
मैम मैम
yes,
अगर ये हर्ट्ज में नहीं पूछता तब क्या करते?
you just have, if there is no Like they are not asking in hertz, then you have a chance in terms of angular frequency.
तो मैम ओमेगा
That
को
thing
क्या
is
बोलेंगे फिर?
there is omega is the angular frequency and f is your natural normal frequency. There is just factor of 2 pi. And I think for the angular frequency, your unit is radian. But
हम कई बार क्वेश्चन में हम कई बार ओमेगा करके आ जाते हैं, कई बार एफ करके आ जाते हैं, तो इसमें मतलब कंफ्यूज हो रहा है बहुत ज़्यादा।
that you have to decide from the unit what they have
अगर मैम
given.
नेचुरल फ्रिक्वेंसी पूछ रहा है तो हम एफ निकाल के आएंगे, ओके, राइट ना मैम?
हाँ हाँ.
और अगर डायरेक्ट एंगुलर फ्रिक्वेंसी पूछ रहा है तब हम डायरेक्ट ओमेगा करके आएंगे।
Hmm. But then you have to always remember what is your final, unit.
ओके मैम, यहाँ पे पोटेंशियल एनर्जी का टर्म आपने लिखा v इक्वल टू हाफ के x2 - x1 माइनस x02 माइनस x01, ये समझ में नहीं आया ये टर्म।
Actually, in previous all question जो हमने सॉल्व किए थे उसमें हमारा ऐसे था कि पार्टिकल फिक्स था एक स्ट्रिंग पे ऐसे. So
यस
in
यस
that
मैम।
case, your string is not moving. So you can take its position as 0, and here you can take as position as x1. So your final extension of the string will be x1 minus this position 0. So it will not change. But here your particle is not attached to any string. So it might have its initial positions like this, which is extended to this x1, x2. So since both the type of motion, x1 is also changing, x2 is also changing. So let's say you have initial rest position of your system where you have mass m1 and m2 and its position is x01, x02. So your initial displacement of your spring is x02 minus x01 square. And since your final is like you have stretched your string and it will become x1 and it will become x2. So you have to calculate what is the final displacement of your spring. So that will become x2 minus x1. So you can write it like present length minus original. It's just to make your solution more accurate. Otherwise, you can also directly, it might be correct. So you can directly use x2 minus x1 as your spring final displacement. In that case, you do not have to change your coordinate system. Eventually, you are just writing x2 minus x1. But there might be condition in exam where they give you an initial position, then you have to use this formula. It's a direct formula here, but main correct one is this way. So if you
ओके
have
मैम।
doubt, is it clear?
यस मैम।
Okay. So let's solve this question from K 2013. Consider two small blocks, each of mass m, attached to two identical springs. One of the spring is attached to the wall as shown in figure. The spring constant of each spring is K. The masses slide along the surface and friction is negligible. The frequency of one of the normal mode of the system is. So we have to calculate one of the frequency of oscillation. Now your motion is attached to a wall and at one position. So since you have two masses m1 and m2, so your kinetic energy will be 1 by 2 mx1 dot square for the two particles, and you can write the potential energy. So this one is 0 and this is at x1, this is at x2. So what is the extension for this spring? It will be x1 minus 0. So your total displacement for this spring is x1 square. Oh, x1. So you can write your potential energy 1 by 2 kx1 square. For this spring, your displacement will be this is x2 and this is x1. So this is x2 minus x1 for this spring. So this is how you write your potential energy. So you just expand this expression, write it in more clear form, x1, x2. Write your kinetic energy as a matrix form. So write, calculate all these coefficients T11, T12, T21, and T22. So if you differentiate your this expression, you can calculate these expressions. And then you have potential energy. And in its matrix form, you have to write V11, V12, V21, V22. So V11 means differentiation with respect to x1 twice. So you have x1 here, you also have x1 here. From that, you are ended up having 2k, and there is x1 here as well. So I hope you are able to know how to calculate these off diagonal element as well. Put that into your secular equation. Omega square multiplied by this term will become omega square m minus v means minus 2k. Then there's this term 0 minus v means plus k. So this is your secular equation and your matrix is 2 cross 2. So you have omega square 2 values. And when you solve this like matrix, I just write it omega square m equals to s just to make the calculation simpler. It's just how you are solving your quadratic equation. I just solve it using b square minus 4ac. Now, if you look at this expression here, 3 plus minus square root of 5 into k by 2. And this is the value of omega square. So, if you calculate 3 square root of 5 by 2, this is also valid for omega square since it is positive. And if you calculate 3 minus square root of 5 by 2, since the square root of 5 is always going to be less than 3, that means this term is also positive. So both the value for omega square is correct. But since in your option all the answer are given in positive form, so you have just take it here as a positive answer, but otherwise both the answer is correct. And they have asked you just for one of the normal mode. So that's why we have selected only one.
मैम
There
जो
might be
सेकंड यस मैम सेकंड फ्रिक्वेंसी है वो हमें इमेजिनरी मिल रही है इसके कारण नहीं आ
this
रहा
one
है
is
राइट ना
not imaginary here.
मैम ओमेगा स्क्वायर इक्वल टू क्या आ रहा
3
थ्री
minus
प्लस
square root of 5.
यस तो मैम
So square root of 5 is less than 3, na?
हाँ हाँ हाँ
So this term is
चार वैल्यू
positive.
मिलेगी
That
फिर मैम
means
चार वैल्यू
yes.
मिलेगी फिर जिसमें दो
हाँ,
इमेजिनरी
so
होगी राइट
हाँ हम्म,
ओके मैम
नहीं
गॉट
दो
इट
दो नेगेटिव होंगी, not imaginary. So if you
तो मैम
calculate 3 minus square root of 5, it is a positive number. So
यस मैम
inside omega
पॉजिटिव
square, so this is also give you a positive answer. So you have two value of omega which are positive and correct.
ओके
So if this is a multiple choice question and both the options are given, then you have to tick both the options. Since only one option is given, so we have just ticked one.
मैम ये क्वेश्चन 2 मार्क्स के आते हैं क्या
या ये 2 marks का ही था.
ओके मैम
Okay. So this question is again the like previous one from GATE 2011. Two bodies of mass m to m are connected by a spring of spring constant k. The frequency of normal mode is. So in that case, you have to calculate the frequency of normal modes. So you have a mass m1, m2, which is connected by a spring. So the initial thing will remain as it is. You have to write the kinetic energy and then potential energy same as the previous one. The only thing that is changed is the masses given to you. They are given mn to m. So your secular equation, only the factor which is changed is this kinetic energy matrix. It will become in terms of mn to m. Potential energy will remain as it is. And when write omega square t minus v equals to 0, you can see that then so it's a simple definition. You can see that you have omega value which is 0 that will correspond to like your motion can be like translation as well in this system, and omega equals to square root of 3k by 2m. So in option there will be root of 3k by 2m. Just only mass is changed, everything will remain as it is. This mass change will change your kinetic energy. Okay, and this was the question from K 2020. And this one, I think I have also solved when we are talking about the stable and unstable equilibrium. The potential energy of the particle mass is given, and what is the angular frequency of a small oscillation. So one thing that you have to remember when solving this question is, whenever they talk about the small oscillations, means they ask potential energy to be a function of x square. All the term about the uh, power which are greater than square, how to neglect those terms. So only then it is possible to have small oscillation. And if they are giving you force, then you have to take your force only proportional to displacement. For the power greater than this one, you have to neglect these terms. So for example, in this case, we are given sine functions. So sine functions you can always expand in terms of higher terms now. You can have 1 minus x squared to factorial plus x to the power 4 by. Now for cosine, this is the expansion. So you can also have higher order term, but if they are given in the question that the motion is a small oscillation, then neglect these terms. So you just write your ux, since it is given in terms of kx square minus pi by 2, and I think you are familiar with this notation that if you have sine of pi by 2 minus x, you can always write it as cosine of x. And since it is a negative, so you have sine of minus x equals to minus of sine x. Just take negative outside, change it to sine, expand your cosine function, neglect higher order terms, and you are ended up having the exact potential that you have to deal with. And now you have to calculate angular frequency. So angular frequency can be written as a 2 differential del 2 v pi del x square pi m, and at equilibrium position. And how do you calculate equilibrium? Put del v by del x equals to 0, the value that is coming from this expression for the axial equilibrium position. So you are given ux, you have to write angular frequency, differentiate this term equals to 0, that give x equals to 0 as the equilibrium position. Differentiate twice, so by twice differentiation there is no x term. So just write it inside this expression. This will give you your angular frequency as k square root of a by n. Okay. So this was the questions from this small oscillation part that I have found on previous GATE exams. So there are two questions that was asked in on Telegram. One is a plane polarized EM wave in free space at t equals to 0 is given by this expression. What is the for a plane polarized wave, you are given the electric field. What is the magnetic field for this system? So magnetic field you can calculate directly using this expression. So you have to calculate what is the propagation vector k for your electric field and what is its polarization direction. The one which is given outside is polarization, and the one which is given in the expression inside exponential or cosine of, like you may given cos kx minus omega t. This will give you your propagation vector. So you are given kx as 6x plus 8z. So from here you calculate k vector by taking the gradient of this, which is 6, 8x cap, 8z cap, and you have to normalize it to calculate the unit vector of propagation vector. So normalization is just 6 square plus 8 square, that is 1 by 10. So this will give you your k cap vector as 1 by 10, 6 in the I cap plus 8 in the k cap. And since your n cap is given to be the y cap direction, z cap direction here, j cap, sorry. So just multiply these two terms and you are ended up having a propagation polarization direction for your B vector. So this is your polarization vector for magnetic field. Just put it inside this expression. You are ended up having your magnetic field. There are a lot of questions that are asked like that in GATE exam. They are
मैम
straightforward.
हेलो
Yes,
हेलो मैम इसमें ये कैसे पता चलेगा आपने यहाँ पे ई की पावर में 6x+8z तो ठीक है वहां से लिख लिया लेकिन -10 ct कैसे कर दिया
minus 10 CT. Okay, this term
यस मैम यस
that see, either you are given in the question the full form like A cos kx minus omega t. If they are not given, but in option they are given that 10 CT. So that you have to assume it's just misprinting in your question. So I have seen that जो तुम्हारे ऑप्शंस थे ना उनमें सब में सीटी था और इवन तो क्वेश्चन में सीटी तुम्हें दिया नहीं था सो इसका मतलब यही था कि उन लोगों का मिसप्रिंटिंग है कि क्वेश्चन में उन लोगों ने सीटी नहीं लिखा एंड दैट सीटी मींस you can always write your omega as omega by c is equals to k, I guess. There is a relation between omega equals to kc. So if you write this, you can also write it as kc into t. So you just take k mod. So this is the magnitude term actually. The magnitude of k you can take outside and it will become x minus ct. So your magnitude is 10 na? So you can always write it like that. So I think this formula is used, but in question this is not given, but in option there is a density. That means you have a misprinting in your question. I hope you understand.
या मैम
Okay. So there is this question 36 from GATE 2014 exam, and this is also asked on Telegram. So a ray of light inside a region 1 in XY plane is incident at a semiconductor boundary that carries no free charge. So you are given a boundary of dielectric interface and there is no free charge on this interface. This is given, that means sigma is 0 here. Now the electric field at any point P which is at 45 degree and in plane polar coordinate is given. So you are given an electric field E1 is at this point P, but it is given in polar coordinate system. So you are given in r theta coordinate. So emerging ray in region 2 has an electric field E2 which is parallel to this x-axis. If epsilon 1, epsilon 2 are the dielectric constant of the region 1 and 2, what is the ratio epsilon 2 by epsilon 1? So this question is related to the boundary condition lecture that we have covered, but we have not covered this question, so we will complete it here. So basically you are given electric field in polar coordinate system. So they are representing unit vector by ER cap, which is very much actually just notation. ER cap means R cap in your coordinate and E theta cap means theta cap. So I think you are familiar with R and theta in polar coordinates. So they are just notation difference. So if you wanted to write your electric field in XY coordinate system, since angle is given in terms of XY coordinate, so write your R cap in XY coordinate. Similarly, write your theta cap in XY coordinate. I think you know how to write this. If you have XY coordinate, R theta means R is the radial direction outward, which making an angle theta, and theta is perpendicular to that. So this is your R cap, this is your theta cap. So if you have to write R cap along x direction, how can you write? You can write component of R cap along x, which is magnitude of R cap cos theta in the x cap direction. This is 1 plus if this make an angle theta and this is 90. So this is also theta. And since r cap make an angle theta with x cap, it makes an angle 90 minus theta with y cap. That will change your theta with sine theta in the y cap. So you can write your r cap in xy coordinate. Similarly, you can write your theta cap by adding 90 plus theta in this, and this will give you r theta in xy coordinate. So you can change your electric field which is given in r theta into xy coordinate system. Just replace r cap by xy, theta cap by xy. So this is your electric field in xy coordinate system. And now if you wanted to calculate ex component, just take only x component here. So this will give you the ex component of electric field. And if you wanted to calculate y component, just take your y. So that will give you the y component of electric field. And now you have to calculate, just change your perspective. See, in our boundary condition, we have solved this problem that if you have electric field which make an angle theta 1 with the interface and it's make an angle theta 2 in another direction, then we have this condition that epsilon 1 parallel component equals to epsilon 2 parallel to epsilon 1 नहीं, electric field parallel component equals to electric field parallel component in this second medium. So I'm not able to give you the correct. See, if this is your medium 1, this is your medium 2, you have electric field which make an angle theta 1 here with the normal, which is normal to this medium. So basically here your surface is circular. So your normal will be perpendicular like this. But just to make this thing simple, I just try to give you a plane. I'm just making the thing complicated. Okay, so I'll just give you a simple example that the question for boundation. For precondition, you have to know which component of it is parallel to your boundary and which is perpendicular to your boundary. Here your boundary is circular, so you have to know which component of electric field is perpendicular to your circular boundary and which is parallel to your circular boundary. And this problem we have solved for the normal plane boundary. In that case, we have shown that in lecture on boundary condition that if you have electric field which make an angle theta 1 in medium 1, it's make an angle theta 2 in medium 2, and we can always uh, break it into two components. One component which is parallel to the interface E1 parallel and which is perpendicular the interface E1 perpendicular. And then we apply the boundary conditions which says that parallel component electric field is going to be continuous. However, perpendicular component is continuous by surface charge density. And since surface density is zero in this portion, perpendicular component we have the epsilon E2 perpendicular. And since E1 perpendicular is, and then we break this component like E1 parallel can be written as E1 of cos parallel component is this one. So E1 parallel is sine theta of E1. And from that we have shown that there is a relation between epsilon 1 and epsilon 2, which is tan theta 1, tan theta 2. So I'm going to use this formula directly. So if you have any confusion for this formula, you can go to this lecture where we have solved for 10 weeks. Now come back to this circular boundary. In this question, we know what is our electric field in xy component. They are given coordinate, but we have changed it to xy coordinate. Now we have to see what is the angle that is electric field making with this normal to this circular boundary. So you have to calculate what is the angle that electric field is making normal to this boundary, and we call this angle as alpha, which is given by tan inverse of y component by x component. So this is the angle that electric field E1 is making with the perpendicular to this. And electric field which is making to us that is parallel to the x-axis. So at the position point P2, electric field E2 is kind of making an angle 45 degrees normal since it is parallel to the x-axis. And for E1 we see we have this condition. I think you are able to see that. This angle is 42. This angle is 45 degrees. So this angle is 45 degrees. And we have this surface here. This is 45. But this is our E1, which make an angle 21.8, which is calculated by calculating XY component of electric field. Right, this is the condition that we have here. So we have to calculate what is the initial angle theta 1 with the normal. This is 45 minus the total is 45. We just subtract it to calculate what is the initial angle that the electric field is making with the normal to the surface. And finally, tan theta 2. So we just take it epsilon 2 by epsilon 1 since we have to calculate this ratio. So this is become just tan 45 by tan theta 1. So basically you have to just understand what is the angle that electric field E1 is making with the normal to this interface initially and finally. Finally is easy because it is given in the question that electric field is parallel to the x-axis and they are given that angle to be 45. And for initial angle, you just have to set from this 45 degrees. And if you calculate these two ratios, this is your answer 2.32. And if you wanted to know how this expression for theta came, you can just go back to this lecture of boundary conditions that we have solved for plane case. I think this question is from Aparna. Are you able to get it?
Clear, ma'am.
Okay. So even though we have a lot of questions left from GATE exam that we have not solved,
Ma'am, that small angle is 45 minus
minus the
21.69.
angle. Yeah.
Ah, okay, clear.
Okay. So have you people solved the last year question from physical mechanics? All these problems, or you are still left with some of them? We will solve some question in next class. If you, we can have a class just for classical mechanics questions if you want. Or is there any topic that you want me to cover? Just let me know.
Ma'am, generating function, that part.
जनरेटिंग फंक्शन को जनरलाइज फॉरियर यूज करके जनरेट करते हैं वो.
Yeah, yes.
Oh, that also cover your Poisson tracking part also. Oh, we will cover that in next class. Okay.
Okay,
Next
ma'am.
class will be on Sunday. So today is
Okay.
better.
संडे को
हाँ.
मतलब परसों ही?
या मैंने इसमें 2 ब्रेक लिए थे कॉन्फ्रेंस की वजह से. So today's class is for that compensation. और ये मेरी एक क्लास रहती है तो मेरे को वो भी कंप्लीट करनी है. So we
तो
can
मैम
solve.
परसों तो हमारा मॉक टेस्ट है 2 से 5.
Okay, so you may not come. I just create video and post it on YouTube. You can watch it and post your
मैम
down.
मैम परसों मतलब इवनिंग में नहीं कर सकते हो क्या मॉक टेस्ट के बाद?
Test
कुछ
part.
हमें डाउट पूछने होते हैं तो
Okay. Actually, mock test के बाद एक क्लास होता है उसमें.
मैम मान लो किसी
जनरली.
और वार को से मंगलवार बुधवार गुरुवार सोमवार को भी फिर मॉक
Okay.
टेस्ट है.
Then we can take classes on Friday. Every this time, how we people find this 6 to 7 Friday.
ओके.
Okay, so we can take classes next Friday. कंपनसेशन क्लास वाले नहीं. उसमें हम डेट क्वेश्चन सॉल्व करेंगे प्रीवियस ईयर के. जस्ट क्वेश्चन सॉल्व क्लास होगी.
ओके मैम.
बट मेरे को संडे में तो लेना होगा क्योंकि यू कैन आस्क योर डाउट इन फ्राइडे क्लास में नेक्स्ट वाले में. बट मैं संडे में क्लास तो लेना पड़ेगा क्योंकि एनपीटीईएल सेशन है मेरे को.
ओके मैम.
ओके, तो क्लास तो सेट नहीं होगा. ये हो सकता है कि मैं यूट्यूब पे वीडियो डाल दूंगी इसे बना के. फिर जस्ट वॉच एंड जो आपको तुम्हारे डाउट होंगे वो नेक्स्ट लेना फ्राइडे.
ओके मैम.
ओके. थैंक्स. विल फिनिश दिस क्लास.